morning, everyone. So in the next about 1.5 hours, actually you will hear different presentations from the core development team, CDT, covering different aspects of the DataMed, the prototype indexing system from Katie. So for my talk, I'll primarily give you an introduction and focus on the UI part, the search engine part of the DataMed, and also provide a demo. So go with a very brief introduction of the CDT. Then I'll focus on DataMed architecture and show you a workflow about the search engine and the main components. Also, 2 more slides about the user engagement in our development, and then I'll provide about 10 minutes demo. And at last, I'll highlight some of our next steps. So we have 4 roles for the CDT. First, our primary job is to develop a functional prototype for DDI, now called DataMed. The second, we will implement guideline suggestions from all different working groups. For example, the DATS metadata standards from the working group 3 was implemented in the prototype. And then we will also integrate the systems modules which are developed by the pilot project and the supplements. I'll show you some examples in the DataMed website. At last, we will engage end users to DataMed development and evaluation. So this is a roadmap actually Lucila already showed previously. So I'm not going to the details. Basically, this is our development plan as highlighted in the white paper. And a few major events I'm trying to show here. One is the limited access release, the version 0.5. in the February of 2016. And in the June of 2016, we actually released version 1.1, which is a public accessible version. And right now we are between the 1.0 and version 1.2, which is going to be released in the February of 2017. So just a very quick summary about what we have done in the past year. So primarily, like the main contribution, I think, is, as I mentioned, 2 different versions for the DataMed. And on the data ingestion part, we included 23 data repositories, implemented the DATS data metadata model, and now we have enhanced modules for indexing the pipeline, trying to automate all the different components in the indexing pipeline. And on the search engine part, we developed the NLP service, terminology service, and the Elasticsearch-based searching algorithm, and I'll show you later. And on the evaluation side, we created benchmark data sets. We did some user surveys and part of the usability testing. So I will cover the search engine in my talk, and Jeff will give you more details about data ingestion, and then Travel and Todd will each give you some more details on the evaluation about benchmark data set creation and the usability testing. So this is the overall structure of the DataMed architecture. So we are getting, somehow I lost my animation. Is this a PDF or this is that's a PDF. Oh, okay. Yeah. All right. Then, so basically, different repositories, online data sets, and all other sorts of information will be collected to the metadata ingestion pipeline we have, going through indexing, and then on our end, we are building this user interface for searching those data sets. And the terminology and the NLP server will contribute both to the indexing part as well as the searching part. And my talk here will primarily focus on this part, and Jeff will provide more details on the data ingestion. Oh yeah, this is messed up, so sorry about this. I made the animation, I didn't know we're converting to PDF. So basically what I'm trying to say here is that this is a typical search engine like you all familiar with, like Google, so it's a web-based application. And I'm showing a screenshot of the DataMed, and I'm just trying to emphasize this is the architecture. We use the typical MVC model for web application. So the controller will responding for the user input, such as the queries. Then the model will be responsible for talking to the database, retrieving the results, and the viewer will provide the output to the end users. And this is actually the workflow for the search engine. So we start with the user in the left middle, and the user specified query. Then this query will go to the NLP service. So we will extract the concept from the query. And then this concept pass to the terminology server. The terminology server will return like a synonyms about this concept and expand the query to refine the query over here. Then through the Elasticsearch, you will return both the facets as well as the ranked results. So the user will look at the results and interact with the system, select the different facets to further filtering the results. Go to the refine query again, do the lower loop again. So I'll provide some details with each of those main components, the NLP, terminology, and the Elasticsearch. Just to give you a quick example about the NLP and the terminology server. So let's say we have some textual description of the data set here. And the NLP server will actually go through those texts, recognize concepts in those descriptions. For example, over here, it recognizes the COPD, which map to a mesh concept with this mesh ID M0384655. So once this concept ID was recognized, the terminology server will go to the existing terminology and look at what are the synonyms related to this concept based on the existing terminology. You will find all the other synonyms like, for example, this is chronic obstructive airway disease, or even the abbreviation COPD. At the meantime, it will also provide the children's of this concept that might be also included for the search. So this is how we use the NLP service as well as the terminology service. Both of them actually available as a RESTful API. So if later for the comments, if they want to talk to BioKaty to get those results, then we can quickly integrate based on the web service. And by the way, the entire DataMed is also available as open source software. So we have also documentations about how to install, how to reuse the code. So a little bit more details about the NLP server. So as I said, the goal is to extract a biomedical concept. We're actually doing two different types of NLP processing. One is trying to use the mesh as a backbone. So we'll extract whatever concept is covered by mesh, because mesh is also used for PubMed searching, so we think it's a good fit. In addition to that, we are also extract like 5 specific type of entities: disease, chemical, gene, biological process, and the cell lines, because we thought those are of particular interest to a lot of users when they search in the data sets. And now the NLP will be used in 2 places. One is trying to parse the query that user enters. The other is trying to index the metadata texture field in the, for example, as a description field. And for the implementation, we really make sure existing tools and have some locally developed systems. For example, we use the MetaMap Lite, which is a new version of MetaMap. MetaMap is the one used at the National Library of Medicine to index articles to generate mesh terms. And we also develop some machine learning-based entity recognition system, for example, based conditional random field algorithm. Also have some rule-based system. So this is a very preliminary evaluation on some different NLP components. So for the mesh term, we use MetaMap. We haven't evaluated much yet. On the gene, disease, chemical, cell line, we all use machine learning-based methods to extract those entities. And the performance right now is not ideal. One of the reasons is we actually use the annotated corpus from biomedical literature to train the model. Then when we apply this to the data description field or the title, actually the situation is a little bit, the 2 corpuses is not very similar. So we're still optimizing the performance for the NLP part. Our goal is actually to improve precision. Every term we recognize, we hope it will be correct. For the terminology server, we really want to leverage existing terminology in the biomedical domain to facilitate search. Like I said, the terminology server can be used in multiple places in the entire search engine. First, we use to expand the terms during the index of the metadata description. Second, during the search, we use that to expand the queries, and we also use for auto-completion and spelling checking. There are a lot of terminology available, so it is not feasible to including all of them because it will introduce a lot of noises. So what we did, we focused on terminology contains condition, chemical, gene, procedure, etc. And we now included 6 comprehensive terminology. It adds up together about 1.7 million concepts with about 7.5 million relations. So this is a quite big number. What we used to hold this information, this knowledge, is a graph database called Neo4j. It provides very robust ways to store and retrieve those relations and concepts. And we also use the SiteGraph, which is the interface, the RESTful API for Neo4j. It's actually very fast when talking to the Neo4j. So the response time when we test is often less than 0.1 second. For ranking algorithm, currently we use the Elasticsearch implementation of the Sultan's vector space model, which is the default search engine within Elasticsearch. And for some databases like Geo, we do have the citation count, so we also can be ranked by citation. The plan is really we will took the advice from working group 8 as well as the evidence from the dataset retrieval challenge to see any new relevance ranking algorithm should be implemented in the DataMed, and also the citation count, publication time, etc. So here I'm just trying to show you some ways to filter the results. We have different facets filtered by the repository, filtered by the data type, also filtered by the accessibility, defined by the working group led by George. And the next slide just showing when you actually go into a data repository, because some different data repositories provide different type of metadata. Some provide more details. So we actually, for each data repository, we also generate different facets for you to look into the details of the repository. I also will show you when I do the demo. So remember, the other mission is to actually really engage the user during the development of DataMed. So we are actually focusing on 2 areas right now. One is how to talk to the data repositories, how they can contact us and to submit to the data repository index request. This is also the work together with working group 11 led by George. And the other one is we really treat seriously about the feedback from the users, how we actually handle all the feedback from the user is also a critical thing for the development. So this is a slide showing we have built a repository submission workflow. So repository can go online, fill a form, and we will open up an issue in the GitHub, and someone will be responsible for acknowledge the submission. Then we assign the work to the responder as well as the evaluate. Go through all the different process, record the progress in the GitHub as well. Then we will further contact the user to see if this repository will be readily to index by the Katie very quickly. So this is a workflow of user feedback workflow. Basically, we have 3 different ways to take the feedback from user, and we'll also record this in as a GitHub issue. We will have someone actually sitting there, look at all those issues, tag them to different categories. This is a usability issue, this is a function problem, and then we go through the development team and discuss and assign the work, re-implement in the DataMed, and contact user to see if they're happy. If they're happy, we close the issue. Otherwise, we're going to re-enhance the whole workflow, restart the whole workflow again. And this is a very briefly statistics about total issue we have. We have about 133 issues. We closed 88. We still have 55 remaining issues to be solved. And this is the different categories of the. Okay, so that's pretty much about my introduction for the slides. So I'll go to the website and show a demo, maybe a 10 minutes demo. Thanks. So this is the main interface of the DataMed. So you can type datamed.org and show up this interface. The search in the middle, this is a typical search bar like what you see in Google. Over here, we provide some statistics about the current data set we have. Right now, we have 23 data repositories. Click this link, you can see all the repositories. And the total data set is about 650,000 data sets in this search engine right now. This lists all the top repository with the highest number of data sets. This is some news about the feature development. And here listed the pilot project we have been integrated to the DataMed. And this is a simple search. We also created what we call advanced search. This is something similar to like a PubMed. You can build your own Boolean query. So over here, you can select, say, different fields. The title contains something, the author, the description, and you can say add a criteria. You can specify this is and or not. So basically, you can build a quite comprehensive Boolean queries for the search. Let me go back to the main page and just try to type something. Melanoma. So while you're typing, we actually will dynamically just show this term in different data types, protein structure or gene expression data, and within each data type, what are the data repository contain these keywords and the number of data set in each repository. So if you see something interesting, you can click right here. Let's just try to see all the data sets, so I don't click anything, let's just hit enter. So here, what you can see is the returned results. On the left side, this is what we call the facets area. So you can filtering further by repository or by the data type. Let's say if I'm only interested in gene expression data, if you click this, it will actually only limit all the data set to the gene expression data, and you can see we actually have 4 repositories contain gene expression data. Let me just unclick it. And over here, you can also filtering by the accessibility. For example, if you only want to data set which is downloadable, you can actually filtering over here. And you can also rank the data by the relevance. On the right side here is the most recent activity, the terms you have searched recently. And this is showing the synonyms based on our terminology, right? Like you type melanoma, what are the synonyms we used in the search? And if you're even interested more about the search query, we provide the detailed search query which you can actually log into this. To see what kind of synonyms have been added to this search query. And we also have a function to share the results you got. For example, if you're interested in those 2 data sets, you can actually select them. Then you go to this send to. But we have the different ways to share those collections you have selected. You can save it as a file. You can email to someone. You can build a collection and save it to your account. This actually requires you to have an account with Biocading. But I'll show you, you can also sign in with using your Google account. And also, or you provide some kind of citation format. So right now, I'm just going to clear this selection. So this is pretty much the main function around the return the results. But we have a little bit more function if you select a specific data set, say PDB. go to this PDB data, like I said, each data repository, they may provide actually different type of metadata, some of them with a lot more details. So what we create is called detailed view of the repository. This is what view might be different for every single repository. So as you can see, the view, each record here is different from the view across all the repository. And what's also interesting here is on the left side, if we look at facets, those are the facets actually specific to PDB. You can look at the record the journal information, so we actually list different journal. You can filter by journal, filtering by organism over here. And also, for PDB, for example, we have a citation count, so you can also sort by the citation count. And another aspect I want to show is about one of the pilot projects we have been integrated into this PDB data repository, which is called IC-Delph, which is led by Todd Johnson sitting there. So I click this. What this does is different ways to visualize the results. For example, we retrieve, like say, 1,000 data sets related to the keywords, and this program will clustering the results, do some analysis, and show some visual analytics to this data set. For example, it has the word cloud here. This is a different cluster for the return the results. And if you click one of the cluster, you can actually see within this cluster how the different keywords showed up in this cluster. So basically provide a different way for visualizing the output. So this is one of the pilot projects which has been integrated to this DataMed. Now let's go back to this DataMed website. So I further want to show, if you click one of those data repositories, what we're showing here is the metadata based on the DATS standards. Right now, this is still DATS 1.0, and we're actually mapping to DATS 2.1, which actually will provide many more metadata fields over here. And what I also want to point out, we also implement algorithm for similar data sets. Travel data provide this algorithm to show data sets similar to this one you selected. And meanwhile, we'll also integrate the grant information. So grants related to this data set is also showing here. I think pretty much that's what I want to show about the data set, how you search, what are the information will be returned. One thing maybe I also want to show a little bit how we sort of engage the user. So the user can actually provide their feedback, report issues through GitHub or contact us directly. And over here, this is what we talked about, the data repository to submit a request. Say, I want my data repository to be indexed by Barcade. We have developed a form, ask specific questions to assess how ready this repository is to be indexed by Barcade. Then we will go through the workflow I described previously to contact the data repository to start the ingestion pipeline. And this one is showing you actually you can log in with accounts. Either you have account with Barcade or you can log in with your Google account actually. We will allow you Google account associated with Barcade. Then all the search activities, all the collections you save will be saved in with your account. I probably don't want to mess up Elizabeth's Google account. So I think pretty much that's it about the interface. And let me just go back to the slides. I think I have one or two more slides. Okay. Okay. So I also have just grab statistics based on Google Analytics of the DataMed website, just to quickly show how many users we have. We have right now daily about 25 users, and since end of June, it's like about 2.5 months. Totally, we have about 574 different users. Their average page view is about 3 pages. spending 3 minutes on the website. This is still very rough, and we're actually developing our own tracking system, trying to provide more details. This is just to give you a quick view how many users we have so far. And in terms of next step on the data ingestion part, our goal is to including country-class data repository with map to the DAT format 2.1 and develop a more automatic tool for data ingestion. So the repository can actually do some of the work by themselves. And on the interface side, we may going to redesign based on the user feedback. Some users saying the search box is not obviously, so we are thinking about redo that. And there's also a plan where I actually have some visual analytics component to be added to the results. And the ranking algorithm, like I said, based on the benchmark data set, we're going to do more solid evaluations and decide on the new relevance ranking algorithm. And on the evaluation side, with the benchmark data sets ready, we're going to do more performance evaluation and the usability testing. We are developing a user tracking system. We will record all the single clicks they go through the website, provide more kind of inside information about how users interact with the website. And this the team consists of a team from UCSB, Oxford, NIH, and UT Health, as well as the pilot project team and the supplement team members. And thank you, everyone, and ready for questions.